Greetings everyone, welcome to video number 18, part 2 of 2 in the project management series presented by Process Geekoid. Today's agenda we will be going over specifically the schedule network diagram and determining the critical path and other schedule related concepts such as total float and free float. Recall that the schedule network diagram is an output of the sequence activity process. As always, please subscribe, like, and comment. So let's move forward. As a refresher, the ITTOs of the sequence activities process are shown here. So the purpose of this video is to show that we are taking the input, specifically the schedule management plan, activity list, activity attributes, and milestone list, and using the precedence diagramming method, create this project schedule network diagram. So we will be creating this diagram using the dependencies in place and sequencing the activities as needed and constructing this diagram that follows the precedence diagramming method. So on the PMP exam, you'll be typically given the list with schedule duration next to each task, as well as any immediate predecessors and dependent tasks. Based off of this list, you'll be asked to calculate various metrics such as critical path, which is the most common, also the near critical path. Now, in short, the critical path is the longest duration path, the maximum that a project can go on. The near critical path is where you are close to the longest duration path but have some wiggle room, and that is known as float. The first step in creating the schedule network diagram is by determining the sequence of activities. Any activities that have no predecessor come out of the start node and are placed in a vertical fashion. So in this example, activity A, B, and D have no predecessors and are immediately placed after the start node, as shown here, A, B, and D. Next step is to go after the activities that have dependencies and place them accordingly. So now we have C that comes straight after A and B. Then you have C that comes straight after E, and then you have F, which is tied right after D, and then G comes straight after E and F, and then H comes straight after G. And that is shown right here. We have A, B, and D, which have no predecessors. Then we have C coming straight after A, F coming straight after D, and then E coming straight after C, G coming straight after E, and F, and then H. So then the next step is the exciting part, where the critical path is being calculated. Simply put, the critical path is the longest duration path. Before we do this, we must put a 4-quadrant grid on top of each activity that will guide us in determining the float. So this grid is going to have the early start, early finish, late start, and late finish, and have the total slack or total float in the middle. So recall that the ES or early start is the earliest possible time to start an activity. Early finish is the earliest possible time to finish an activity, or EF. LF, or latest possible finish time, is where the latest possible time an activity can finish but keep the overall project on track to finish within the specific duration which we will calculate. LS is the latest possible time an activity can start an activity but keep the overall project on track to finish within the longest duration, which is the critical path. LF of a task or late finish is the same as the late start of the next task. So here you see that to create this crosshairs, so we take the durations, we have them listed here. So 0 is earliest start, 0 plus 4 is 4. Then for activity C, 4 plus 5 is 9, that's early finish. Then you have to take that 9 plus 5, that gives you 14, that's early finish for activity E. Same thing, we take that for each and every activity. 0 plus 3 is 3, 1 plus 3 is 4. So that calculates the late finish and late start. D, activity D, early start is 0, early finish is 1. 0 plus 1 is 1. Then you have So we're doing a forward pass. Next, we take 1 plus 2 is 3. Then you have to take the next step, which is going to be taking into consideration, since E and F are both going to G, you will now have to take into consideration that the longest path that is holding up the activity is going to be E. So now you have to take 9 plus 5 is 14. You can't take 3 because you still have to finish for activity E to finish. So 9 plus 5 is 14. 14 plus 5 is 9 is 19. Now the only activity tying into H is going to be 19. 19 plus 6 is 25. So that gives us the forward path. Now the backward pass is going to tell us, now we have to take 25 minus 6 is 19. 19 minus 5 is 14. Now we take the 14 and feed that into the late finish of the previous activities, and then subtract the duration to give us the LS, the late start. So we have 14 minus 2 is 12, 14 minus 5 is 9. And then you take the same thing here, 9 minus 5 is 4, and then here you take 12, feeds into D as the late finish, because this is a late start. Late finish is here. So these both have to be the same. 12 minus 1 is 11. That is the late start. And then now for the fun part. Now that we've calculated all of these differences, you'll see now that the key pieces here are the free float, early start of current activity minus early finish. As you can see here, you have some free float of 11 days. Or 1 day, 1 minus 0, early start minus early finish. So you have a float of 1 day. Here you have a free float of 2 days. And then here you have a free float of 5 days. So that goes to show that there is some freedom of slack in between activities. But we are more concerned with total float, where we are subtracting the late start minus early start, or LF minus EF, and this gives us the float. So on the exam, the question simply states the float of an activity is total float. Anytime you hear float, it's total float on the exam. Otherwise, it's going to be specified clearly as free float. So most of the time, we'll be taking the LF minus EF, LS minus ES, and calculate the critical path. And you can see here that the critical path is A, C, E, G, and H. And that is typically the total slack or float of path of zeros. So 0, 0, 0, 0, 0. That is the pattern that you will see. The shortcut for the exam, since you only have a minute or so a question, is to just add up these durations. 4 plus 5 plus 5 plus 5 plus 6. That gives us 25. So 4, so A, C, E, G, H gives you 25. Well, let's see. 3, 5, 13, 18, 24. This is going to give you the near critical path. So that could be another follow-up question is, the near critical path would be B, C, E, G, H. And then you have D, F, G, H is a path of duration of 14. So that doesn't really affect us that much. But we'll be most likely be tested on the fact that the critical path is A, C, E, G, H, and the near critical path is B, C, E, G, H. And to refresh the definitions here, total float is what these zeros are showing on top of each activity here. And that is what we want to calculate. And that is the amount of time you can delay any given activity without delaying the project end date. That's why it's a total float or total slack. The amount of time an activity in the overall scheduled diagram can be delayed without delaying the project end date. But the free float is where you have amount of time a predecessor activity can be delayed without delaying the successor activity and still meeting the scheduled baseline and the overall scheduled duration. So that's the key difference. Thank you for watching. Please subscribe, like, and comment.